So in this video, I'm going to talk about why physics is interesting as a field and why it's something we should care about. So physics is the study of the universe, essentially. Everything we can observe, physics seeks to describe, and it does that in a mathematical form. But this is really important because you see physics when you study atoms, and that physics is called quantum mechanics. And then you also see physics on large scale things like galaxies or stars. Basically, what I'm trying to make a point of is physics concerns itself with everything that's observable, and it tries to unify them all together. And that's a big part of science in general. Science, you take what you observe and you make sense out of it. You unify it under universal laws. And every field of science essentially boils down to physics. For example, in biology, as of late there's been a big movement into biophysics. And essentially, a lot of biology early on concerned itself with just studying the chemistry of biology. But recently, people have discovered that there are a lot of interesting dynamics in the cell, fluid dynamics, how the cell moves, how it forms its skeleton, how things inside the cell are transported. And these are all physical processes. And by applying physics to even little small biological systems, we've come to understand them. So physics is really central to all parts of science. I mean, chemistry is actually a direct product of quantum mechanics. That's how we understand it, through the Schrödinger equation. Many principles of chemistry, such as the Pauli exclusion principle and the Heisenberg uncertainty principle, you may not know what these are, but these are actually named after physicists, and they're used in chemistry. So chemistry directly arises out of physics as well. Astronomy, astrophysics, those are all physics being applied on a large scale through something called general relativity. So essentially, it's a tool to study everything. And it's also had some serious impacts on technology in our everyday lives. A lot of people think that theoretical physics is very disconnected, but it's actually produced probably the most important discoveries of the 20th century. And two of these are computers and nuclear technology. These are probably two of the most prominent examples of how physics has affected technology. So computers were only discovered because of quantum mechanics. This is because there's something in a computer called a semiconductor. It's part of how the electricity flows through the computer and makes it work. And to build it, you need to build something called a transistor to build a processor. And you can only do this with semiconductors. But they were actually invented directly as a result of quantum mechanics. It was because of quantum physics that we were able to build computers. Without theoretical physics, our internet and all our electronic devices today would not exist. So the other big example that everyone is more commonly known as nuclear technology is a direct result of physics, theoretical physics especially. And this is because we discovered the immense amount of energy stored in the nucleus of the atom, and we discovered a way to release this through a process called fission. And essentially that led not only to obviously nuclear weapons being developed in the Manhattan Project, which, be it good or bad, had a very, very large impact on the 20th century, undeniably. And it also led to the production of nuclear power, which is actually one of the prominent forms of energy today in a world where we're running out of fossil fuels. So I guess what I really want to emphasize here is studying physics really allows you to branch out and study almost anything. And the possibilities are unlimited in what can be discovered because you're really studying an unlimited system. The universe is a wonderful thing, and this lets you try to investigate any part of it that you please and unify and make sense of why all